This is SpaceTime Series 24, Episode 88. Coming up on SpaceTime, high drama aboard the International Space Station, discovery of a molten core in the red planet Mars, and first evidence of water vapour on Jupiter's moon Ganymede. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The International Space Station is now stable again after Russia's new Nauka Multipurpose Laboratory Module started firing its thrusters, briefly sending the orbiting outpost out of control. For 47 minutes, the space station lost control of its orientation, the station's position being key for getting power from its solar panels and for communications. The incident happened while cosmonauts were inside the new Nauka module for the first time, carrying out their initial leak and inspection checks. Suddenly, Nauka ignited its thrusters, sending the space station out of normal orientation, 45 degrees out of alignment. When Russian mission managers at Star City near Moscow realized what was happening, they fired up the Zvezda module's thrusters to try and stabilize the space station. However, Nauka's thrusters kept firing, resulting in the two modules essentially fighting each other, with Nauka pushing the station out of alignment and Zvezda trying but failing to correct the movement. Eventually, mission managers turned on the thrusters aboard a docked Progress cargo ship. That allowed them to regain attitude control and stabilize the motion of the space station until Nauka burned up all its fuel. The orbiting outpost is now back under full control, flying in good configuration, with NASA Houston Control and Russian flight directors working through the issue, while the Russian Federal Space Agency Roscosmos is trying to determine exactly what went wrong aboard their shiny new module. Meanwhile, JAXA and ESA, the other two major stakeholders in the space station, are monitoring the issue in real time. The incident has caused NASA to postpone the second flight of its CST-100 Starliner spacecraft, which was meant to fly to the space station. The 20-ton Nauka was launched aboard a Russian Proton rocket from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan, docking onto the Earth-facing port of the Zvezda service module.
And for the final few meters, Oleg Novitsky taking over manual control.
Range is about 10 meters. Copy. Range rate is minus 0.08. The crosshairs are aligned. Range is 6 meters.
6 meters now. Novitsky flying the multipurpose laboratory module in for its docking.
Range is 5 meters. The target is in the center, and the crosshairs are aligned, and the range rate is minus 0.08. We copy. Range is 4, and the misalignment is unintelligible. We copy.
Standing by for contact and capture.
We are losing the image. The range is 3 meters. Copy. Range rate is minus 0.1. The target is in the center. The crosshairs are aligned. Copy. Range is 0.1. We're standing by for contact. And once you get the contact and please deactivate. Once you confirm contact, please deactivate PUBPS. Copy.
Contact and capture. Docking confirmed. At 8:29 a.m. Central Time, a long time coming, but has now pulled into port at the International Space Station.
Congratulations, that was not an easy docking. We have deactivated the manual control mode.
The uncontrolled thruster burn started roughly 3 hours after docking. It's the latest in a very, very long string of technical issues which have plagued the development and construction of the 13-metre-long Nauka module, culmination of which has delayed its launch by well over a decade. Moscow first began building Nauka back in 1995 as a backup to the space station's Zarya control module. It was then expected to replace the Pirs docking port module, which joined the space station in 2001 as a temporary addition. But ongoing delays with Nauka meant Pirs ended up staying in orbit for 2 decades. Nauka should have launched in 2007, but was repeatedly delayed by technical issues. Then in 2013, metal contamination was detected in its fuel system. That resulted in a long and expensive clean-out. However, by the time the clean-out was done, several fuel system components had reached the end of their use-by dates, meaning a new fuel system had to be built from scratch, further delaying the launch. As Nauka's launch schedule dragged on and on and on, other systems aboard the module also underwent modernization and repairs, further extending construction. Finally, a launch date was set for late last year, but yet more technical issues pushed that date back to April this year, followed by further problems moving it to July the 15th. Then another week's worth of delays before finally launching, only to suffer this new technical glitch with its thruster once docked. Still, once all the problems are sorted out, Nauka will enhance the capabilities of the Russian segment of the space station, serving as the new Russian docking port and spacewalk airlock for future operations. Nauka also provides 16 outside and 14 inside workstations, and there's room for 6 cubic meters of scientific equipment as well as almost 5 cubic meters of storage, living accommodation for another crew member, and it's equipped with the European Space Agency's robotic arm, the first on a Russian segment. To make room for Nauka, the Russians have jettisoned their long-serving Pirs docking port. Pirs was undocked by the Progress 77 cargo ship, and the pair then went to a fiery grave, burning up in the atmosphere over the southeastern Pacific Ocean, the internationally designated satellite junkyard. It'll still take several months and multiple spacewalks to fully integrate the new module with the rest of the space station. However, its stay might not be very long, with Moscow planning to leave the International Space Station in the next 3 to 4 years, taking the Russian segment of the orbiting outpost, including Nauka, with them. They're now developing a new Russian space station, the first module of which is already under construction. And Moscow has big plans to work with China on a new lunar space base as well. This is SpaceTime. Still to come, discovery of a molten core in Mars, and a new instrument which could help humans live on the moon. All that and more still to come on SpaceTime. New data from NASA's Mars InSight lander has confirmed that the red planet's core is still molten. The stunning discovery, reported in 3 papers in the journal Science, is at odds with previous hypotheses suggesting the Martian core is solidified. The new findings are based on data from InSight Seismometer, which has provided details on the depth and composition of the red planet's crust, mantle and core. The Earth's core consists of a molten outer core surrounded by a solid inner core. Scientists will continue studying InSight's data to determine if the same holds true for Mars. InSight's principal investigator Bruce Bannard from NASA's Jet Propulsion Laboratory in Pasadena, California, says the discovery represents the culmination of a lot of work and worry over the past decade. Bannard and colleagues found the Martian crust was much thinner than they'd expected and may only have 2 or 3 sublayers. The crust goes down some 20 kilometres based on 2 sublayers, 37 kilometres if there are 3. Beneath the crust is a 1,560 kilometre thick mantle, much thinner than expected. At the centre of the planet is the Martian core, which has a radius of 1,830 kilometres. That's far thicker than expected, virtually half the diameter of the planet. The Martian core is composed of iron and nickel, but there's also a lot of sulfur there as well, and that makes it less dense overall than the Earth's core. One of the study's co-authors, Simon Stoller from the Swiss research university ETH Zurich, says it took scientists hundreds of years to measure the Earth's core and 40 years after the Apollo missions to measure the Moon's core, but InSight's taken just 2 years to measure the Martian core. Here on Earth, the earthquakes that most people feel come from faults caused by the tectonic plates of the planet shifting. But unlike the Earth, Mars has no tectonic plates. Instead, its crust is one giant plate. But faults and fractures still form in the Martian crust due to stresses mostly caused by the continued shrinking of the planet as it continues to cool. Being only a third the size of the Earth, Mars is cooling much quicker than the Earth. And our study's authors have spent much of their time searching for bursts of vibration recorded by InSight's seismograph. Once they've confirmed the readings were caused by Marsquake activity and not the wind, scientists examine the primary or P waves, which are followed by the secondary S waves. These waves can show up again later in the seismogram after reflecting off layers inside the planet. So a seismogram's wiggles can reveal properties such as a change in porosity or a more fractured layer. Interestingly, all of InSight's most significant quakes appear to have come from the one area, Cerebus Fossae, a region volcanically active enough that lava may have flowed there within the last few million years. Orbiting spacecraft have even spotted the tracks of boulders that appear to have rolled down steep slopes after being shaken loose by Marsquakes. Curiously, however, no quakes have been detected from the more prominent volcanic regions, like Tharsis. But it's possible that many quakes, including larger ones, are occurring in a way that InSight can't detect. That's because of shadow zones caused by the core reflecting seismic waves away from certain areas and preventing a quake's echo from reaching InSight. This is SpaceTime. Still to come, a new Australian instrument which could help humans live on the moon, and first evidence of water vapour on the Jovian moon Ganymede. All that and more still to come on SpaceTime. Scientists hoping to identify lunar water ice deposits and lunar lava tubes, which could be used to provide protection for human habitation on the moon, have developed a new miniature ground-penetrating radar which would be especially useful for spaceflight. The new device was developed by Melbourne startup company CD3D and tested at the Royal Melbourne Institute of Technology University, RMIT. What makes it special is that it uses magnetism rather than electric resistance to scan deep below the surface. And it's compact. The prototype device, known as MapRad, is just 1/10 the size of existing ground-penetrating radar systems. Yet it can see almost twice as deeply below ground. It's more than 100 metres, allowing it to identify minerals, ice deposits, or voids such as lava tubes. The company behind the device has now received a grant from the Australian Space Agency as part of the agency's Moon to Mars initiative to further develop the prototype, including testing the unit by mapping one of the Earth's largest accessible lava tube systems, the Undra Caves in far north Queensland. CD3D CEO and RMIT Honorary Professor James McNay says MapRad is smaller, lighter, and uses no more power than existing ground-penetrating radar devices, yet it can see twice as deep as existing technologies. He says what makes it unique, apart from its size, is how it operates, using a different frequency range using the magnetic rather than the electric component of electromagnetic waves. The magnetic waves emitted and detected by the device measure conductivity and electromagnetic wave reflections in order to identify what lies underground. Voids and water ice provide strong reflections, while various metal deposits have high conductivity at unique levels. MapRad's initial development focused on facilitating drone surveys for mining applications, with early field tests centred around Australia and Canada using a backpack prototype for mining and mineral prospecting. But being so compact meant it also had some obvious applications in space, where size and weight are at a premium. The system could be mounted on a surface rover or attached to a spacecraft in low orbit. One of the targets would be the tunnels left by ancient volcanic lava flows, which are thought to exist at shallow depths below the surface of both the Moon and Mars. These caves are thought to be suitable for housing space colonies. That's because they provide protection from both meteoroid impacts, high-energy ultraviolet radiation, and other energetic particles. They'd also help provide shelter from extreme lunar temperatures, which can range from over 100 degrees Celsius during the day down to minus 150 degrees at night. Based on their depth and surrounding geology, lava tubes are thought to provide stable environments around minus 22 degrees Celsius. But while space colonies on the Moon might happen in the long term, a more immediate target will be mapping frozen water ice deposits on the Moon. See, water can be split into hydrogen and oxygen, and these can be used for rocket fuel. The oxygen can also be used for breathing, and simply melting the water ice could be used for drinking. McNay says that after the lava tube testing in Queensland later this year, work will begin on optimising MapRad for spacecraft use, making it compatible with spacecraft equipment and other space-based science instrument packages.
A couple of years ago, Amara International, at the request of some mining companies, wanted to work out a way of sticking radars onto drones to map the inside of pits and other things. So they came to me as a sensor designer and Jan Franke from International Ground Radar in Canada, and together we sort of ran a research project. So at RMIT, we designed the new antenna using the magnetic fields rather than the conventional electric fields antennas. And just because I knew from designing some of the things that if we got it to work, it would be way smaller. With the electric field antennas, they have to be quarter wave devices. So if you're working at, say, 10 megahertz, an electric dipole antenna would have to be 7.5 or 15 meters long to get decent response. Whereas I knew from other sensor developments, I could make a magnetic field detector that was a few tens of centimeters long. So
Huge
I guess
difference.
we went ahead and we did a fair bit of design work and a whole lot of testing, and we built the antenna. I guess if you ever take apart an old radio, which has FM and AM, the FM aerial is an electric quarter wave antenna. That's the bit that you pull up and out, and that at around 100 megahertz, that wavelength, that thing has to be about 75 centimeters long to be ideal. But the AM antenna is always inside and is some ferrite with windings around it. And just because it's AM radio, which is around a megahertz, you'd actually need a 75-meter long wire to be any use. So the whole concept is not that new. It's been in use in everyday radios.
Since I was a boy.
Yes.
So
for some reason, no one had tried it in trying to get lower frequency radars to see deeper. They just used the lessons they'd learned from the very high frequency radars and just made things bigger and bigger without actually sitting down to work out, hey, there's a better way of doing this.
And the test now is to see how well it works in a real-world situation, and we can't afford to test it on the moon right now, but Queensland lava caves could be the solution to that problem.
Yes, that's a good moon analog for lava tubes on the moon. We have tested it in mining environments in Western Australia, which are relatively conductive compared to the moon, so they're not a good analog. Much harder to get signal through it. But there, yes, the new radar worked much better than the conventional electric ones, which are much bigger, and it's all pretty much close to twice the depth with no more power. I'm using the same transmitters. And
the idea now is to go to Queensland and try it again there, and then, I guess, pitch it to NASA.
Potentially, there's a batch of sort of integrators who stick different systems together, and some of those are certainly interested in the concept because they've got some part of the payload will be NASA and part of it might be other things. So there are certainly options, and other countries besides NASA are exploring in space. I mean, this radar could have applications pretty much any time someone wants to use one.
That's Professor James McNay from the Royal Melbourne Institute of Technology University. And this is SpaceTime. Still to come, the first evidence of water vapour on the Jovian moon Ganymede. And Russia officially places its new Sukhoi Su-75 Checkmate on display for the world to see. All that and more still to come on SpaceTime. Evidence of water vapour has been detected in the atmosphere of Jupiter's largest moon, Ganymede. This water vapour forms when ice from the moon's surface sublimates, turning directly from solid ice into a gas. The discovery was made in a comparison between new and archival observations undertaken by NASA's Hubble Space Telescope. Previous research offered circumstantial evidence that the 5,268 kilometre wide Jovian moon, bigger than the planet Mercury, contains more water than all the Earth's oceans. However, temperatures there are so cold, water on the surface is frozen solid. Ganymede's oceans lie roughly 160 kilometres beneath the crust. Therefore, the water vapour being detected now does not represent the evaporation of this ocean. The discovery was made when astronomers re-examined Hubble observations covering the last 2 decades. In 1998, Hubble's imaging spectrograph took the first ultraviolet images of Ganymede, and they revealed colourful auroral ribbons of electrified gas. These bands provided evidence of a weak magnetic field. The observations were explained by the presence of molecular oxygen. But the problem was some of the features didn't match the expected emissions of a pure molecular oxygen atmosphere. So scientists at the time hypothesized that the discrepancy was caused by higher concentrations of atomic oxygen. However, more recent follow-up observations in support of NASA's Juno mission combined 2018 data from Hubble's Cosmic Origin spectrograph with the earlier archival images from the Space Telescope imaging spectrograph taken between 1998 and 2010. And surprisingly, it shows there's hardly any atomic oxygen in Ganymede's atmosphere. The study's lead author, Lorenz Roth from the KTH Royal Institute of Technology in Stockholm, says Ganymede's surface temperature varies strongly throughout the day, and around noon near the equator, it may become sufficiently warm for the ice surface to sublimate small amounts of water molecules. And it's these water molecules, which are the origin of the perceived differences in the ultraviolet images, originally thought to be caused by atomic oxygen. As for the molecular oxygen, well, that's produced when charged particles erode the water ice surface. The new findings come as the European Space Agency continues its preparations for next year's launch of the Jupiter Icy Moons Explorer or JUICE mission. JUICE will arrive at Jupiter in 2029, spending at least 3 years making detailed observations of Jupiter and its largest moons, with special emphasis on Ganymede as a planetary body and potential habitat. Ganymede was identified for detailed investigation because it provides a natural laboratory for analysis of the nature, evolution and potential habitability of icy worlds in general, the role it plays within the system of Galilean satellites, and its unique magnetic and plasma interactions with Jupiter and its environment. This is SpaceTime. Still to come, Russia's new stealth fighter, and later in the science report, claims the Delta strain of COVID-19 is more successful because infected people are producing much more of it. All that and more still to come on SpaceTime. Russia has finally officially placed its new Sukhoi Su-75 Checkmate single-engine stealth fighter on display for the world to see. The new aircraft's been designed to compete directly against the F-35 Lightning II Joint Strike Fighter. Checkmate is Moscow's second stealth fighter, a smaller, lighter counterpart to its big twin-engine Sukhoi Su-57 Felon. The Felon is a Mach 2-capable blended-wing body fuselage design aircraft seen as Russia's answer to America's F-22 Raptor, currently regarded as the world's best jet fighter. For the technically minded, the smaller Checkmate is understood to be capable of Mach 1.6, the same as the F-35A, and better than the B and C versions of the F-35, which can only fly supersonically for short periods of time before damaging the aircraft tail section. Checkmate's power comes from a single MPO Saturn Isdelai 30 engine, two of which are fitted to the bigger Su-57 Felon in the same way that the Pratt & Whitney F135 engine used on the F-35 is the development of the Pratt & Whitney F119s, two of which are used on the bigger F-22. Checkmate's operational range is expected to be around 2,000 kilometres, only slightly less than the F-35. Now, by comparison, Checkmate's big brother, the Su-57 Felon, has a subsonic range of 3,500 kilometres, better than the F-22 Raptor's 3,000 kilometre range. The Felon has a higher service ceiling of 20 kilometres or 66,000 feet, about 1,000 feet higher than an F-22, but the F-22 has a far higher top speed of Mach 2.25. Supercruise, the ability to fly supersonically without engaging fuel-guzzling afterburners, and thrust vectoring, a system improving the manoeuvrability of aircraft, are key features of both the F-22 and the Su-57, but not fitted to either the F-35 or its Russian counterpart Checkmate. In the same way that the F-35 is an American export stealth fighter, Checkmate is being touted for Russia's traditional export markets, such as Vietnam and India, with deliveries expected to begin in about 6 years' time. Importantly, Checkmate's expected to cost just a fraction of the price of an F-35, a big selling point for many third-world countries. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study shows that the Delta strain of the COVID-19 virus is more successful than other variants because infected people are producing more of this virus than those infected with other strains. Since first appearing in India late last year, the Delta variant has become the predominant strain in much of the world. The new findings, reported in the journal Nature, looked at some of the first victims infected with the Delta strain in China, and it showed their viral load, a measure of the density of the viral particles in the body, was roughly 1,000 times higher than those infected with the original coronavirus strain. The World Health Organization estimates more than 8 million people have been killed by the COVID-19 coronavirus. There have been over 4.2 million confirmed fatalities and 196 million people infected since the deadly disease first spread out of Wuhan, China. Well, debate continues in medical circles as to whether consuming small quantities of wine could reduce or increase your risk of an irregular heartbeat known as atrial fibrillation. AFib, as it's often called, affects roughly 1 in 100 people. A report in the journal Clinical Electrophysiology shows one study of over 400,000 predominantly white middle-aged people assessed the risk of irregular heartbeat with the amount of alcohol consumed per week. They found that those who consumed very small quantities of wine had a lower risk, while any amount of beer or cider consumption resulted in a higher risk of irregular heartbeat. However, an editorial in the same journal points out that other studies have found the opposite result, showing that even small amounts of wine consumption increase the risk of irregular heartbeat. A new study warns that Australia's multi-billion-dollar chickpea industry is being hit by blight. A report in the journal Microbial Genomics is now looking at the extent of the genetic diversity of this chickpea scotch blight pathogen. The research is a collaboration including Griffith University, the New South Wales Department of Primary Industries, the South Australian Research and Development Institute, and Curtin University. Researchers are now cataloguing the genetic sequences of the causal fungus of Scotch arabi within all major chickpea production regions in order to identify the most destructive members. A new study has shown that sulphur-crested cockatoos teach each other how to open household wheelie bins in search of scraps. Ornithologists reporting in the journal Science have documented how the birds have learned to use their beak and feet to open the bin lids and rummage inside. The big white parrots are very intelligent and they're naturally curious. They're native to woodland habitats across Australia and have adapted well to European settlement and life in urban areas. Scientists watched how their bin lid opening behaviour spread across Sydney's suburbs, extending from suburb to suburb and reaching neighbouring districts more quickly than suburbs further away. And that suggests the new behaviour wasn't popping up randomly, but was being spread through social learning. The authors also found that the birds don't open the bins all the same way, but use different techniques in different suburbs, again suggesting that this behaviour is being learnt by observing other birds. Around the world, there are now more than 1 billion people who have been fully vaccinated against the COVID-19 coronavirus. That's some 15% of the global population. Right now, and these figures are changing every day, Iceland has the world's highest total vaccination rate at over 75% of the population. That's closely followed by Israel, the United Kingdom, Canada and Chile, all getting close to 70%. Belgium, Singapore, Denmark, the United States, Germany, the Netherlands, Austria, Spain and Italy are all reaching the 60s, while Switzerland, France, Sweden and Greece have around 50% of their populations now fully vaccinated. Further down the list are Norway and Finland in the 30s, while Japan has just a quarter of its population fully vaccinated. But you've got to go way down into the teens to find Russia, South Korea, New Zealand and Australia. In fact, many are now describing Australia's poor vaccination performance as a vaccine strollout rather than a rollout. Meanwhile, a survey conducted by the Melbourne Institute has found that vaccine hesitancy across Australia has fallen slightly since the Sydney Delta strain outbreak started, with the largest fall being in New South Wales from 35% down to 24%. The fall in hesitancy in New South Wales is amongst people who were previously unsure, down from 20% to 9.6%. The proportion of people who are not willing to be vaccinated at all remains stable at around 15%. That's pretty well where it's been since the beginning of the Sydney outbreak, and that's similar to what happened during the Victorian outbreak a few months ago. Vaccine hesitancy remains highest in Queensland at over 50%. But Tim Mendham from Australian Skeptics says it's important to realise that vaccine hesitancy isn't the same as being anti-vax.
Why people don't believe in vaccines, some are suggesting that, again, you break it down by categories of the people who are hesitant as opposed to those who will get it, they just haven't got around to it, to those who are first on the queue who got it, and those who will say, I'm never going to get it because they're obviously involved with Bill Gates and 5G and nanobots and all sorts of things. So there are different reasons. Individually, what reasons? Trying to sort of pin down people to categories is fraught at the best of times, but anti-vaxxers more anti-authority than it is anti-science, if you can believe that. They believe they are choosing a particular sort of science which supports their argument. They keep using arguments that are either conspiracy-based or pseudoscience-based, and they believe that the pseudoscience is science. So it's just which brand of science that they want to follow, the anti-vaxxers. If science that is supported by experimentation and evidence, and that the science that is science in quotes that is supported by fear and hysteria, but they believe they're being scientific. So why do people, there's a range of reasons why people are anti-vax, and I would suggest that by and large the vast majority of people, whether they're vaccine hesitants or what, are not anti-vax. At the best of times, the overt anti-vax people would be between 5 and 10%. At the moment, you can add on vaccine hesitancy, which is anywhere from 15 to 25%, roughly, and that makes it look like a large cohort of anti-vaxxers, but the hesitant people are not necessarily anti-vax.
They're just concerned about the side effects from the vaccines that are now available, whether or not Pfizer does cause enlarged hearts, whether or not AstraZeneca is going to be a problem in terms of blood clotting.
Or whether the vaccines will make you sterile and give you small appendages.
Oh, really? These are issues as well, are they? Okay.
Oh, serious issue, mate. All sorts of theories that are out there, obviously, for what the impact of the vaccines will do, right? Forget the horrors of the actual disease. Oh, yeah, there's as many things out there that you can claim caused by the vaccines as you want to make up. But to me, eventually, the vast majority of the vaccine hesitant will move across into being vaccinated, especially as threats arise. You'll see an increase in the number of vaccine takers eventually.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.